So again, talk about long division. So let's start off with monomial division. Whenever we divide by a monomial or a single term, again, we can distribute that 3x squared to each thing. So we can really just turn it into 3 different fractions anytime you divide by a monomial. Okay? So in this case, we want to simplify each fraction individually, of course, keeping the signs that they have. So in this case, 6 divided by 3 gives you 2. X to the 4th divided by x squared leaves us with x squared. Again, you subtract your exponents when you do the division. Minus 15 divided by 3 gives us a 5x. X cubed divided by x squared leaves us with 1. And anything divided by itself is 1. So 3x squared divided by 3x squared just gives us a value of 1. If we have multiple variables, so we got 21, a to the 5th, b cubed. Again, we're dividing everything by 7ab. Plus 63a squared. So everything's divided by 7ab. So again, numbers by numbers, so 21 divided by 7.
3. And like A4, B2, right?
Perfect. Minus 14 divided by 7 gives us a 2.
2AB. A2B, right?
2a squared and b. Yep.
And then 9.
Plus 9a, right? The b's cancel each other out, meaning there'd be a 1 left over. Of course, 1 times anything is just that other anything. So that's our monomial division. Now, if we have something like number 3, where we have w squared minus 7w plus 10 divided by w minus 5. So in this case, we're no longer dividing by a monomial, right? We have a binomial. It's got 2 terms in it. We can no longer just distribute and do that division. One of the ways that we can do this division, though, is by factoring the top. So how could we factor the top? What would it factor into?
W minus 5, W minus 2.
W minus 5, W minus 2. Now, because these 2 things are being multiplied together, I can treat them differently than I could if they were being added or subtracted. So W minus 5 divided by W minus 5. If we have something divided by itself, those 2 things cancel each other out, meaning we're left with just the W minus 2.
Where did the W minus 2 come from again?
The factors. So when we factor W squared minus 7W plus 10, we can split it into W minus 5 and W minus 2. Okay. So number 4. Same idea, we got 4h squared minus 7h minus 2 divided by h minus 2. So again, the first thing we want to do is we want to factor this if we can. What method of factoring would we use? Slide and divide, slip and slide, whatever you want to call it. So 4 times 2 gives us 8. How do we factor that? Or what would it factor into? What are our signs going to be?
Plus and minus.
Plus and minus. So we need 2 numbers multiplied to get 8, whose difference is 7. Negative 8, positive 1. Now we've done our slide. Now we need to do our divide. So take each of those, divide by 4. Simplify if we can. So 8 divided by 4 just gives us a negative 2. And if we cannot simplify, take that denominator and put it back in front of our variable. So we got 4h plus 1 and h minus 2. And of course, we are also dividing by h minus 2. So we've got h minus 2 on top and on bottom. Those 2 things cancel out. And we're left with 4h plus 1. So that works if we can factor it. Now let's talk about if factoring is not possible. So this is where long division comes in. So let's think back to our elementary school years. Let's do the long division of 524 divided by 5.
That'd be 1, and minus 5, and then 24.
So to get 5 into 5, we can go one time. So 5 minus 5. Again, we change that sign. That gives us a 0. Then we bring down that next term. How many times can 5 go into 2?
0.
0, right? So we're going to plug in 0 here. Bring down our next term. How many times can 5 go into 24? 4 times. That gives us 20. Again, we change that sign to our subtraction.
And like that's like a decimal at the end, don't you? Like bring down to 0, and it'd be 8, right?
We would, if we wanted to get the decimal answer. Whenever we're doing this, we're just going to leave it as our remainder. Okay, so we have a remainder of 4. Okay, the reason why is because whenever we're doing our long division with polynomials, we're probably going to end up with some remainders. But we're going to follow these exact same steps that we just did. So in this case, we've got x squared plus 3x minus 43. We're dividing that by x plus 8.
Can I just ask something? How does x plus 8 go into x squared?
So let's.
You finna find out.
Who's going to find out?
So when we did the long division, we did 5 times 1 to get us the 5, right? What times x gets us x squared?
X.
X. So we're going to put x up top. X times x gives us the x squared. Now we also have this plus 8. We need to multiply that by the x as well. So that's going to give us a positive 8x. Now just like with this one where we subtracted or we changed the sign, we do the same thing here. Change the sign of our x squared and change the sign of our 8x to a negative. Now these two things, x squared minus x squared, gives us 0. Then we have 3x minus an 8x, so it's a negative 5x. Then we bring down our next term. And then repeat that process until we cannot do it anymore. So what times x gets me negative 5x? Negative 5. So that gets us negative 5x. Then we also do our 8 times our negative 5. Gets us negative 40. Again, we change the sign. So even though they're negatives this time, change the sign. So they're both positive. 5x and a negative 5x, those cancel out. Negative 43 plus 40 gives us negative 3.
Wait, why did they change the sign?
Change the signs to eliminate that term that we just multiplied to get.
You just
Right.
took long division like a whole other level.
Yeah. So you always change the sign after writing that next row. So the remainder is negative 3. So what we're going to do is we're going to say plus negative 3 over what we're dividing, that x plus 8. And then we're done. Here is our answer after our long division.
Why? Oh my goodness.
So when we have x squared plus 3x minus 43 and we divide by x plus 8, we get the answer of x minus 5 plus a negative 3 over x plus 8.
No cap.
So let's do another one. We're going to do synthetic division next class. So the purpose of long division is dividing polynomials by either binomials, trinomials, or anything bigger. Right? Synthetic division works whenever we're dealing with polynomials where its leading coefficient is 1, but we can use long division any time. So let's look at some more problems.
synthetic division is the one we did earlier, number 4.
No, we haven't done synthetic division. We're going to do that on, I guess, Tuesday. So we got 2n squared minus 16n plus 19 divided by n minus 7. So how can we turn n into 2n squared? Multiply by 2n. So that gets us 2n squared. And we also need to multiply by the negative 7. So that gets us negative 14n.
Wait, hold on. Go to the beginning.
So we have n, and we need to turn it into 2n squared.
Oh.
So in order to turn that into 2n squared, we multiply by 2n. So then we need to change the signs and do our combination. So 2n squared minus 2n squared, those cancel out. Negative 16n plus 14n gives us negative 2n. Bring down our 19. What times n gets us negative 2n? Negative 2.
You're going to lost one, G.
And then negative 2 times negative 7.
I think get 14.
Negative 2 times negative 7.
Negative 2 times negative 7. Change the signs. These cancel out. 19 minus 14 gives us 5. I cannot turn an n into a 5. So this is going to be our remainder plus 5 over n minus 7.
That's so much with my mom.
Yes, this makes a lot of sense.
That's
I
so
can
sense.
see why people want to become math teachers now.
So let's do another one. We got 10p plus 6 as our divisor. And we are dividing 10p cubed plus 6p squared. Now here's something we haven't seen yet. Notice all of these have been going down by 1 degree each time. This time we're going from a 6p squared to a 9, meaning we want to actually put in a placeholder for our p value. Okay. So 0 times p gives you 0. So it's not like we've changed the value of this equation or anything, but we just got a placeholder. We're holding its spot in the division. So then, what times 10p gets us 10p cubed? P squared. So p squared times 10p gives us 10p cubed. P squared times 6 gives us 6p squared. Change your signs. Those cancel out, and this time those cancel out as well, which is 0. In this case, we really didn't need the placeholder because we had a 0 there, but if we didn't, we would need it. So we can go ahead and bring down our 9. But we can't turn a 10p into a 9. So that's our remainder. So plus 9 over 10p
P squared
plus 6. So our answer is p squared plus 9 over 10p plus 6.
Yes. Yes. Indeed.
Let's do the last.
I think I might become a math teacher after this.
No, we're done.
So fun. Teach students how to solve this.
So we got k cubed minus 17k. So this time, again, we've got a missing k value. So let's go ahead, put that placeholder in. And this time, it really is necessary to put that placeholder, right? If we don't, we're going to have a lot of congestion when we're writing our answer. So what times k gets us k cubed?
K squared.
k squared. So k squared times k gets us that k cubed. K squared times 5 gets us 5k squared. And then change your signs. So k cubed minus k cubed, those disappear, but now we have 0k squared minus 5k squared. It's going to give us a negative 5k squared. So if we didn't have that placeholder, you would have been putting that negative 5k squared under your 17k, and you can't really combine those, so that's why that placeholder is necessary.
Copy this.
I see.
So then we want to bring down our negative 17k. What times k gets us that negative 5k squared? Negative 5k. So negative 5k times k gets us negative 5k squared. Negative 5k times 5 gets us negative 25k. Change your signs. Of course, the k squareds cancel out. We have negative 17k plus 25k. Gives us an 8k. And bring down our 32. To turn k into 8k, we're going to multiply by 8. You get 8k, and 8 times 5 gives us 40. Change your signs. These cancel out. 32 minus 40 gets us negative 8. So then we're going to say plus a negative 8 over k plus 5. Any questions on the long division?
I think I already did this on my own.
I'm
How is it gonna be my future? I'm not going to the grocery store to pull this out. All I'm saying is, how is it more complicated? I think I already did this on my
It
own.
was long division, you just made it 10 times more
It's not regular division.
He pretty much took math and English, threw it
harder.
into one, and said divide this.
But guys, I mean, you're following the same steps every single time. It's like
I hope whoever created long
it's a
division.
little bit, but now let's do a trinomial division. So this time, so this is where the long division comes into play, because we can divide by any given polynomial. So this case, we're dividing with x squared plus 2x minus 1. And we are dividing 2x cubed plus 7x squared minus 4x plus 7. Okay. So again, first step. What do we do to multiply x squared to get 2x cubed? 2x. Multiply by 2x. So 2x times x squared gets us 2x cubed. 2x times 2x gets us a 4x squared, and 2x times a negative 1 gets us a negative 2x.
Wait, so we take that 2x and multiply it by everything on the outside?
Yes.
Okay, now I'm starting to click.
And then next step, change the signs of everything. Right? So this becomes a negative, negative, this becomes positive. Combine your terms. This first step should always cancel out that first term, right? Then we're going to have things left over for the most case. 7x squared minus 4x squared, or you can think 7 minus 4 gives you a 3x squared. Negative 4x plus 2 minus 2x. Bring down your last term. What do we multiply x squared by to get 3x squared? 3. That gives us 3x squared. 3 times 2x, 6x. And then negative 1 times 3, -3. Change your signs and combine. 3x squareds cancel out. -2 and the -6 becomes more negative. -8x. 7 and 3 is 10. And we cannot turn an x squared into an x. So this is our remainder. So plus, we have a -8x plus 10 over x squared plus 2x minus 1. And that is our long division.
She thinks her long division is hard. She's in fifth grade. I'm just like, I don't know.
Take this home to her and give it to her.
I'm gonna be like, you gotta solve this.
Okay,
This is your
I'm
new
gonna my
long
dad, like,
division.
look at how math revolves.
but this is it. This is what we're doing today. Just long division.
You said it like it's